As I promised in the previous segment, without assuming any prior knowledge, I'll start about how to think programmatically. What I mean by that is, suppose I ask you to say add 2 to 3, okay. So 2 plus 3, and then so all of you know that the answer is 5, right? Now, but if you break it up, basically what you are doing is which you have acquired a skill of using this symbol, okay. That means you have added, in fact, what do you call, means counting three objects which are whole objects to another whole 3 objects, and so you are now seeing that 5 objects are there. So that skill which you have acquired, and maybe we will assume that you know how to add and subtract, okay. So 3 minus 2 is 1. Now if you are understanding these two statements, then I think you are quite equipped with what we are going to discuss now in terms of thinking programmatically, okay. Now if you know addition, let's start only with addition, okay. So this segment will not even assume that you know subtraction. If you know addition, can you do this multiplication, say now 2 times 3, okay. So now I am not assuming that you know multiplication, and you also should pretend that you do not know multiplication, and you have only the addition in your weaponry, okay. Then can you perform this multiplication task, okay. Now how do you do that? Multiplication means repetitive addition, right? So you can think that, okay, you are adding 2 plus 2 plus 2, or so 2 you are adding 3 times, or you can think that 3 you are adding 2 times, okay. So this also you will get a 6, this also you will get a 6. Now when you do not use these known shortcuts to do many things, and when you start doing the same thing in a stepwise manner and performing a repetitive action, that is what I call thinking programmatically, okay. So the person who doesn't know multiplication, how to perform that thing, or if you suppose your calculator, you are using a calculator and the multiplication key is not working for a moment, but still in the exam you have to perform it, so at least you can carry out this, so to do the multiplication, so and repetitive action, that's very important. Now another example I'll give you, suppose I ask you to say 1 plus 2 plus 3, like that. If I tell you to add up to 100, okay. So obviously if I assume that you know how to add up to say n, so n into n plus 1 over 2, so that formula if you know, then you can immediately use this and calculate, or else you can actually invent this formula if you are like Gauss, and you can invent this formula and calculate. So that is called the analytical thinking, okay. So this is called a closed form formula to calculate such a thing, and you can use that or invent that to do the job. But suppose you are not Gauss and you do not know this formula, then is it not possible to do this only by addition? Obviously it is possible, because today we are assuming that you know addition, right, how to add. So just keep on adding 1 plus 2 plus 3 with the result whatever you are getting. So 1 plus 2 you are getting as 3, then 3 plus 3 you are getting 6, 6 plus 4 you are getting as 10. So like that you keep on adding. The only thing is that you have to have a lot of patience, and that's it. So no special skill is required, no special analytical knowledge that is required. So that is what I call thinking programmatically, or thinking in repetitive steps. Okay, so always in any given condition, any given problem, first thing we will have to look for is what is the repetitive step which we need to perform. If you can figure that out in a given situation, then definitely you know how to code it. The rest all is very anybody can do. Okay. So once you know the vocabulary, obviously you can just write it down. But the main thing, most important thing is how to break the problem into or see the basically thing into repetitive steps, in the form of repetitive steps. Yeah. So so then for example, if you know only this, now can you think of calculating, say I'll tell n factorial, okay, and then suppose is for n, n is equal to 10. Okay. Now you do not know what your calculator suppose doesn't have a factorial symbol, that's fine, but you know that multiplication is a repetitive addition, and this involves, suppose somebody tells you that factorial is nothing, but you just have to multiply 1 into 2 into 3 up to like that into n. Suppose somebody tells you that this is nothing but this, then you know how to for now we are assuming that you know only addition. So then you will think that okay, this I can do because this is just addition, like that I can add at 1 2 times or 2 just 1 times, that's fine, I'll get this, and then whatever comes here by doing that exercise, then you are having this again 2 into 3, this problem again you can do the repetitive calculation, and that is what is called looking for a problem in to convert that into a form where repetitive simpler steps are being performed. So that one should practice in all the problems which you will encounter as an engineer or as a scientist to do programmatically. Okay, so what I'll do, I'll give you some problems and which can be simplified down to just addition. Okay, for example, yeah, so factorial, multiplication, then if I tell you that if you know subtraction, then you can always do the division if it is properly divisible, right? Suppose we are talking about division of two numbers who are actually divisible, okay, by one and one by the other. Suppose I tell you that 10 divide by 2. So what basically you are doing? You are doing you are subtracting 2 from 10, and okay, you are counting 1. Okay, so one step you are counting the steps of number of subtraction, then it's you are left with 8. Then again you are subtracting 2 and you are counting the step 2, and that is say 6, and 6 minus 2 is 4, you are counting say 3. Now 4 minus 2 is 2, it's 4, and 2 minus 2 0, and it is 5th. Now just by knowing subtraction, you suppose your division key also is not working on the calculator, you can always divide this. So this is what I am saying, thinking in terms of repetitive steps to perform a more difficult thing which is not allowed to do as such. Okay, so now this step only will keep on changing in our problem even when we go to solve, say, the most difficult differential equation for a given problem. There also we will break down just to simple repetitive steps like addition, subtraction, nothing else, and then you will realize that okay, programming is nothing but breaking the bigger problem like this division, which is a big problem now because we don't have the switch working. So to break down into smaller problems. So this you get convinced by thinking about many problems which you can break down only in the terms of plus or minus. For example, can you calculate GCF of two numbers? Can you calculate LCM of two numbers? All those things you start thinking about. Then in the next segment we will be talking about one more thought process that goes into programming along with the repetitive steps. So that is when to stop. Okay, so see you in the next segment.